Hey guys, I am going to teach you how to do ionic bonding. I just want to remind you that we will still have our test as soon as we get back from our snow days. I'm trying to record this video through my phone, so it might not be the greatest quality, but I'm just trying to go ahead and start working on the next unit that we're going to be talking about, and that is going to be chemical bonding. First thing that you were supposed to do was watch the YouTube video I posted on my website over the oxidation numbers and the octet rule. The next video that you were supposed to be watching was the ionic bonding and what it talks about ionic bonding. And what I'm going to do is teach you how to write down the formulas for ionic bonding. The first thing that you're going to need is going to be your PowerPoint. I mean, not your PowerPoint, your periodic table. So I'm going to go ahead and flip my phone and show you the periodic table. So this is the periodic table that you are going to need, the one that we've been working on. Okay. Now you need to write down, if you have not done so, the oxidation numbers of each group, and that's the number on Sharpie that I've written. All right. So first, I want to tell you what an oxidation number is. An oxidation number is how many electrons an atom has that can share, gain, or lose. Okay, if you are positive, remember we talked about those, you are going to lose electrons. You're going to give them away because you're positive. Now, if you are negative, you have a negative oxidation number, that means that you're going to gain electrons. You're in the negative side, so you want to take in electrons. Okay, the main goal is, like in the octet rule, is to have 8 electrons in your outermost shell, and that is the main goal. That's why elements come together, so they can be happy, and we talked about that. The only one that we really don't worry about bonding a lot is the noble gases. And why is that? Is because they have 8 electrons in their outermost shell, so they are happy. Okay, so let's look at some of this information. All right, so I'm gonna put it right here on my computer so you can see it, and hopefully it's clear. All right, so let's look at group 1. If you see, group 1 has an oxidation number of +1. So everybody in that group is going to have an oxidation of +1, meaning that they're going to lose 1 electron. All right, let's look at number 2, and you need to write this down, and if you haven't, please add this to your periodic table. If not, you're going to have to memorize them. All right, let's look at group number 2. Group 2, the alkali earth metals, they have a +2, okay? So that means that they're going to lose 2 electrons. Now we have the transitional elements, and we said that not to worry about those because I will give you those. Now let's look what happens here to the right. Now group 13 does not have 13 oxidation numbers. It has a charge of a +3. Carbon group has a plus and a -4. Those are the special ones because they're going to share electrons. Now, what happens to as you move on with your non-metals? The -3, so the nitrogen group has -3, the oxygen group has -2, fluorine has an oxidation of -1, and at the end, noble gases have 0 because, again, they have 8 electrons on their outermost shell. Now, let's look at the periodic table for just a moment. If you see on this periodic table, you have a staircase, or the ladder that we call. Remember that every element that is touching the ladder is a metalloid. Now, metalloids have properties of metals and non-metals, and we work with those, as we work with our periodic table. Now, the only exception to that is aluminum. Aluminum is always a metal. Now, everybody on this side of the periodic table, okay, all of them are non-metal elements. All right, so now that we have talked about that, now I want to talk to you about ionic bonding, and that's what we're going to be talking today. So ionic bonding is when you have a metal plus a non-metal coming together to form a compound. Okay, so how do you write the formula? How do you know how to do this? So that's what we're going to do. So I'm going to give you a step-by-step process on how to write ionic bonding. And then, of course, at the end of this lecture, you will do the practice that you will have to turn in to me at the end of the day by 10 o'clock tonight, okay? So let me go ahead and set up my notebook in front of my computer so you can see the steps. All right, so these are the steps. how to write the chemical formula for ionic bonds. So it's going to be based in 3 steps. So please, please, please take notes. All right, so let me flip to the next page. All right, so let's just start with this first, okay? Here it says what you're gonna have: sodium plus fluorine. Sodium is a metal and fluorine is a non-metal. Therefore, they can make an ionic bond, okay? And remember, ionic bonds is a metal plus a non-metal. So if I bring the periodic table here to you, if we have sodium found in period 3, group 1 is a metal. And if we go all the way over here, fluorine is a non-metal. So ionic bonding is a metal plus a non-metal. So we can do this. So step number 1, what are you going to do? And again, please excuse me because I am trying to focus this for you guys. So all right, so step 1, write the element symbol. So we're talking about sodium and we're talking about fluorine. So we're going to write down sodium, okay? Sodium and the oxidation number, which is a +1. Why +1? Because it is found in group 1. And I told you that the oxidation number for group 1, everybody in group 1 is going to have a +1. It's positive, meaning that it's going to lose electrons. All right, so now let's look at fluorine, which is in blue. Fluorine, the element symbol is an F, and it has an oxidation of -1. It's a non-metal, and everybody in group 17, the fluorine group, the halogens, is going to have an oxidation of a -1. So hopefully we're following the steps. So if you need to write this down, just pause the video and write the information. Now, let's go to step number 2. Step number 2, it says crisscross the oxidation numbers. Crisscross applesauce. What does crisscross mean? That you're going to cross them, okay? So you're going to write down sodium and the oxidation numbers. If you notice, sodium's oxidation number is going to give, so that's why it's losing the electron to fluorine, okay? So it's going to fluorine. Now, the oxidation number for fluorine is going to go to sodium. Now, let's look at the note at the bottom. Same oxidation number with opposite charges, they cancel out. Okay, so if you notice, +1 minus 1 in math is what? Is 0. So that's why they cancel out. So let's look at step number 3. And again, stop the video so you can write out the notes. Oh, I'm sorry. And again, please, I'm trying to do this with my phone. So, all right, so step 3, write the ionic bond end result. So the end result is sodium fluoride. Now, if you notice, you're going to say, well, what happened to the numbers? Well, the numbers, they cancel out. But in chemistry, when there's no numbers on the bottom, we're going to imply that there is a 1. All right, so it's not technically a 0. We're just implying there's a 1, but we just don't write it down when we're talking about chemical formulas. And that's only when we have a +1 or a -1 charges. Now, also, again, let's go back to the note. If they have the same charges with the same number, but different charges, they're going to cancel out and we do not write them down. Okay, so make sure you take note to that. All right, so let's do another one. Let's look at magnesium plus phosphorus. Can they make an ionic bond? All right, well, we're going to go to our periodic table, and if you notice, magnesium is a metal and it has an oxidation number of +2 because everybody in group 2 has a +2. Now we're going to move further down the periodic table, and phosphorus here is colored in green, but we know is a non-metal because everybody on this side of the periodic table after the ladder is a non-metal. So phosphorus has an oxidation number of -3. So what do? Step number 1, write down the symbols plus their oxidation numbers. So magnesium and phosphorus. Oxidation number is +2. Why +2? Because they're in group 2. Group 2 always has an oxidation number of +2. Phosphorus, P. Why -3? Because the nitrogen group has an oxidation of -3. Okay. So, step number 2. Step number 2 says crisscross applesauce your oxidation numbers. Now, if you notice, the oxidation numbers are going to the bottom of the letters, not on top, to the bottom of the letter. So magnesium is losing the number 2 to the phosphorus. And the 3 is going to go to the magnesium. All right, so step number 3, you write down the proper ionic formula. So Mg3, remember, the 3 came from the phosphorus and the 2 came from the magnesium because you crisscross them. The numbers do not go up here, they go on the bottom. If you put the numbers as exponents in math, it's wrong. It has to be as a subscript. Okay, so make sure you take note to where the numbers go. You just cross them out. All right? So that's pretty much what ionic bonding is. So make sure that you pause the video so you can take notes if the video was too fast. So what you're going to do for your assignment. So you're going to go to my webpage. Okay, it's going to be missgoodoldscienceclass.weebly.com, and there you're going to go to classwork, and you're going to, hopefully you already watched the octet rule video, the ionic bonding video, and my video. Once you are done watching those videos and taking notes, now you're going to do the assignment. So let me show you what your assignment is going to look like. Alright, so this is your assignment. The first thing that you're going to do is fill in the chart. Protons, neutrons, electrons. Valence electrons is the electrons found on the last shell. Remember, is it a metal, non-metal? Does it gain or lose? Okay, and the oxidation number for that element. Then you're going to write down the ionic chemical formula for the following elements. And this is just how we played on the PowerPoint. Alright, so hopefully that makes sense. If you have questions, please email me at marlene.goodall@halka.org or tweet me. You are to turn in this worksheet or this assignment to me via email, or it has to be through my email. So it has to be turned in to me via email by 10 o'clock tonight. Alright, good luck, and I will hopefully see you Thursday. If not, I will see you Friday. Bye-bye.